Welcome everybody to the webinar Bringing the Intelligence to the Edge. Today, AI at the Edge project, the organizer of this webinar, and in collaboration with DAIS project, we'll talk about overall network architecture for future telecom. My name is Neva Linder. I work at Ericsson with network management and automation, and I have been for the last 3 years working as a work package architecture leader for AI at the Edge. I will be your host for today, together with Irene Fakin, our AI at the Edge project manager. Irene, could you tell us more about the agenda for today?
Sure. Thank you, Neva, for this welcome, and welcome everybody to this second webinar of the AI at Edge webinar series. As you can see on the screen, the agenda of today will be divided in 3 parts mainly. The AI at Edge architecture, in which we will present, of course, the architecture of our project. Then you will see the architecture of the DAIS project, and we will conclude with a panel in which we will discuss the intelligence on the edge. Without any further ado, let's welcome Jovanka Adzik of Telecom Italia that will present to us the AI at Edge architecture.
Thank you, Neva and Irene. I will proceed with the AI at Edge architecture. Yes, as you can see immediately here, we have in the AI at Edge project, in the work packet 2, we studied and defined the overall architecture with the main and principal objectives to cover and to provide definitions for network and service automation platform together with the Connect and Compute platform. And that had to be managed with the support of AI/ML functionalities, capabilities. As you can see, there are new components, new interfaces, and particularly places where to include intelligence. In particular, we provide intelligence in platform where you can see, let's say, red heads over here that provide AI/ML support for management of the Connect Compute platform underlined on the near or far edge. Moreover, you can also see the places for on-platform intelligence where we provide the possibility to deploy third-party applications powered by AI/ML functionalities in order to provide better end-user experience for various application domains. Moreover, our overall architecture, as you can see, provide data pipeline flows, which are a very important capability in order to be ready and able to deal with the needs of the overall data and ML pipelines orchestration. So we can say that network and service automation platform, as you can see, should be service-based architecture, particularly including different domains of the network, such as RAN, core, but also edge, and also including third-party components. Moreover, there is end-to-end platform orchestration component, which means, as you can see, multi-tier orchestrator that is powered by intelligent orchestrator component. Very important component as enabler of AI/ML-based decisions. For example, for better placement of the artificial intelligence functions on the Connect Compute platform. As you can see, there is also new component. There are also some new components such as Model Manager, which are very important component in order to provide coherent and complete management of the overall life cycle of the AI/ML models, from the training, inference, placement, and performance monitoring point of view. So this is our overall architecture, which in our mind are providing the most important components for the future networks beyond 5G and 6G, where connection and computation will be brought to the edge of the network, and will be managed in a coherent and a common way in order to provide benefits for the already well-known applications that need lower latencies, data privacy requirements that could be achieved processing data as close as possible to where the data are generated, so at the edge, in our opinion, of the overall platform. So Connect Compute platform extend already known MEC applications orchestration with AI-specific requirements and needs, such as dealing with the overall life cycle management due to the needs to replace and to retrain AI/ML models when specifically needed, both in platform and on platform AIFs. What we think are the key elements of the AI system architecture. It's let's say summarized here. That is the way to put in platform AI, to have on platform AI, of course, on the same platform, then to deal with data and ML pipelines and governance, to provide end-to-end system orchestration and management on the distributed, maybe highly distributed, and decentralized Connect Compute platform. So in order to fulfill the first two requirements, let's say first two key proposals, EDGE defined the AIFs, as you can see here, as a general concept, with defined interfaces in order to specifically deal with AIF in platform or on platform. Particularly relevant is the data pipeline and ML models lifecycle management, and what is also relevant, it is to avoid so-called already present AI silos, to have reuse, to enable reuse not only of the pieces of the data pipeline, but also reuse of the AI/ML models already trained or not. That was, in our opinion, one of the main focus of the AI system architecture, to avoid AI silos with reusable data and ML pipelines. And as you can see, end-to-end orchestration provide the overall orchestration of the resources from various network domains to run core edge, but also orchestration of the third parties application in a way that it can be, let's say, guaranteed end-to-end quality of services. And then in distributed connected and compute platform, we also defined quite new interfaces that you can, of course, find more details in our public deliverable. Just to bring your attention to the situation today and where we think in AI EDGE the evolution is going and have to deal with. Today we have, of course, already ML models, artificial intelligence included, and running in specific layers of the network domains. Let's say sort of AI silos. What we are proposing, and in the next future, very close future, we see the data-driven infrastructure as a main component and main enabler of an close to, let's say, AI native approach, which means data ops, ML ops, AI as service concept. And eventually, what we see is evolution towards multi-domain and cross-domain orchestration, always based on data-driven infrastructure, but cross-domain, which means cross-network domains and resources domains, but also third-party application domains. That will be further objective, further topics to be exploited, how to guarantee closer integration and orchestration with third parties. Thank you. That is for now all. I will be part of the panel and will be happy to answer your question and to discuss with colleagues about intelligence on the edge. Thank you.
Thank you so much, Jovanka, for your presentation. I think that we should go directly and welcome Sasi from DAIS.
Thank you. Thank you, Neva, and thank you very much, Jovanka, for can you see my screen?
Yes.
Okay, so maybe I'm new to this AI at EDGE, so probably I thought of giving a kind of introduction to the DAIS project and also how we, kind of got into the architecture part. So it's not as, clean, neat architecture as you saw from Jovanka, but let me see. I will just start presenting this one. So that I can see the screen. I think if the screen is good enough, I will just flip through the slides. That's easier. So DAIS is actually a big EU project, a sister project for AI at EDGE. So this has got 47 partners in 11 countries, and RISE is the coordinator for the project. So we have got three different kind of objectives. One is develop EDGE AI electronic components, okay, and then develop EDGE AI software. And these software components and hardware components has to have these three different properties. It should be self-organizing, it should be energy efficient, it should be private by design. So this is the goal of DAIS project, and we want to integrate these components into the cloud and fog, and then apply in different industrial domains such as digital industry, digital life, and transport and mobility. So our actually starting point is slightly different. We start with different applications and partner kind of requirements. So we collected something like 400 plus requirements from the partners, which are all somehow connected to these domains, and they want to use more and more intelligence, and they want to bring the intelligence to the edge. But are they fully covering the whole spectrum? This is not sure, because everybody is addressing some part of it. So the application level, basically in the industry kind of things, there is a huge thrust on using digital twins. And when you use digital twins, there is going to be a vast amount of data being generated. How do you really get this data into the cloud? If you get into the cloud, you are into the trouble of having the latency issues. So in a time critical manner, if you want to control the digital industry applications, you need to use the edge. So how to do it in an efficient manner? So this is one focus. And in the digital life applications, we are looking mainly at the security and privacy. Of course, security and privacy is important for the industrial applications as well. And for the transport and mobility sector, we have got multiple use cases where we want to really look into, for example, take care of, forest fires and how to really kind of make distant support systems. So there is a lot of interesting use cases. And our research is actually kind of in 8 supply chains, we call it. Supply chain is like a team of people who are interested in a particular theme and then working on different technological developments. We have 13 proofs of concepts. It's basically a kind of an idea which is actually put into use in a very specific context. Probably one partner works on it. We also have system level 14 huge demonstrators. So I actually is the kind of leader for a work package 3, which is looking purely on the software aspect of it, which is called WP3, which looks at secure and privacy preserving software environment. And in this environment, basically we have got 4 different supply chains. Okay, there is an underlying supply chain which is called enabling software, and a supply chain which looks into the coordination orchestration aspect. One supply chain which looks at security and privacy, and one looks at the communication technologies. So there are 4 supply chains, different partners involved in them, and 13 proof of concepts which are going to integrate all of these technologies. So essentially it's the same, like you have got the device level, and some look at the edge level, some look at the higher level. So when we started, we had this, I will not go into the detail, whole bunch of technology themes and topics which we need to cover, which starts from very low level, device drivers or middleware into the security policies or into IPDS systems, and very wide variety of things. We had, as I mentioned, the slides will be available to you. There is 13 different POCs of very diverse, requirements. So what we did was so we look at the high level requirements. We look at the requirements of the POCs, we look at the requirements of the demonstrators, and we thought what can be a DAIS architecture. And the answer we come up was it was very difficult to have one architecture like Jovanka present. Maybe one day before we complete the project, we'll have a more cleaner representation of architecture. But we knew that there is a lot more heterogeneity in the context, in the requirements, in the components, lot more, heterogeneity. So we had 4 different dimensions of this DAIS architecture, which I will very quickly go through. One is the software, enabling software part of it. It looks at only the software components what we are developing. Components could be for the application level, or it could be for the components what are enablers for making this edge fog continuum. So these components, we basically looked at all the user level components being made and then grouped them into what map into different cloud level or the edge level, which are concerned with the security, privacy, which are at the device level. So we grouped them into multiple boxes. It's basically categorizing them, but their the actual usage or the characteristics or the constraints will come from the other three supply chains. So you can see there are 64 components which are being developed by software components being developed by different partners. They fall into one of these categories with well-defined interfaces, well-defined requirements which are at that level needed. Okay, and when we get into the coordination between these components, once they get deployed into different services, we need to coordinate and orchestrate them. This was part of SC3 activity. So basically what they had is this probably could be looked something very similar to what Ivanka said. So here again, we have got two big middleware persons, like one called this EDGE, which is made by Sensitive and Radiators by ATA. There is another middleware also. So the middleware is the kind of data brokerage which will try to kind of integrate or make interoperability between multiple AI frameworks, multiple communication paradigms, and multiple building blocks like Docker, FileWare, Kubernetes. So you name it. So we had all these different requirements from different vendors, different partners. So we put them together into an SC3 architecture, which talks about the orchestration elements, the interoperability aspects. Then coming back to the security and privacy, it was security architecture was a bit more easier, but privacy was more looking into the general GDPR regulations and the compliance aspects. So there is a whole gamut of requirements which were looked into in the case of security and privacy. We come up with a security architecture which looks at standard security thing of incident detection, intelligence sharing, and data privacy, and then having a dashboard which will kind of present you the details. There is also an attack simulator which uses digital things to test different cases. So that is security aspect. There is also for this service, each of the security services or privacy services are made as a kind of services, microservices, which could be called by your application. Of course, it is going to add into the execution time requirements, but we have some POCs do not use this kind of if they're time critical or resource constraint, they are not going to use the services, but they have their own way of managing. So our main focus was how to really kind of connect them together and use them. And then finally coming to the communication technologies, which are, if you can see this work package 3, it has got 4 different things, and communication is basically how do you really do the dynamic orchestration and adaptability. So there were 3 different proof of concepts in that one. And there again, we faced a bigger issue of how do we really do this orchestration. So in looking at these 3 different use cases, we arrived at a solution which could be used in all the 3 proof of concepts. And the idea is each of the, so in this case, actually, one of the proof use case is looking at, wireless sensor network and TSN for critical applications. And in that case, they are going to use an SDN controller, which is kind of configuring the whole network and then trying to do the reconfigurations. Everything is onto a SDN controller. In a different proof of concept, the link manager will take over the development aspects and the whole configuration control. So each of the securities and communication technologies were done independently. So we have kind of, like 4 different perspectives of the architecture, and we continue to work on individual, proof of concepts in building the themes. Now the generic software architecture design is completed. We have got the way of coordination between the AI components is defined. We have got the implementation of all these components. What is remaining is basically to integrate and test all these POCs into the demonstrators, and we have got this 8 demonstrators. What we expect at the end is to do evaluations of how they perform. Like you can see, n number of pathways from the device to the cloud or device to the edge and back in all these use cases, POCs and demonstrators. And they are going to use very, very different diverse context diverse technologies. And then we hope to have some kind of an evaluation which will provide generic recommendations and guidelines which are usable mainly for the application community. So this is our status right now. If you need further details, these are the people who are involved, different SC leads, as well as the project leader, Anders Lindgren, Håkan, Luis Campbell, Paula Schiatti, and Fondas. Thank you for being able to share our DAIS related information with the AI Edge team. Thank you very much.
Thank you. Thank you so much, Professor Sassi, for the presentation. And well, after these two inspiring architecture presentations, we would like to invite our speakers also for the panel. I will be your moderator for today, even though I'm also participated in the EDGE. I would like to share my views. But you have heard from Jovanka, Adzik from team, from Professor Sassi, Professor Per Edling. I would like to. Why don't you introduce yourself?
So I'm Per Edling. I'm a telecom professor at Lund University. I'm very, proud of all that we have achieved, and I feel like we've demonstrated now that we can do edge computing. We haven't done it in a large scale, but I think we're at least at the doorstep, knowing that this shit is doable and we know how.
Oh, very nice words, Per. So Jovanka, Sassi, you can put on your cameras. So I invite you all to actually discuss a little bit more, because we heard, I would say, two different projects. I believe that hear from you, Sassi, that we see really this software architecture speaking higher, kind of louder. And I believe that for the EDGE from the beginning, we thought a lot about how the current kind of a telecom network would kind of support this AI, these new possibilities that the AI cloud orchestration would bring to that, not only for the networks, but for the applications on top. And actually here, what we see, there are some challenges and actually open questions that we reflect on during the EDGE. And then perhaps I can start with you, Per. What is your view, and what does prevent us, the current telecom network of 5G, to fully embrace AI?
5G has now been around for a while, and edge computing is a very central part of this. Edge computing has not been around for a while, and then, of course, one secretly asks the question, is it really needed? Maybe we can do with mobile phones and cloud, but we know, you see this from this chart, for instance, that yes, it is needed. In AI at Edge, we have this autonomous vehicles use case. So we go in a roundabout. If we don't have edge computing and to send data to the cloud, each self-driving car can send their position and velocity vector and stuff, and you can avoid collisions with other autonomous cars. Of course, you will hit everything else. So if there is some old guy there in an ordinary car, that will not work out. But if you have edge computing, you can have cameras in the roundabout and analyze the traffic live. That data is too big to send. So you can achieve a lot more with edge computing than you can do with cloud. If you do e-health, like Sassi here one of his use cases. Yeah, that's a matter of a kilobit. You know, you can do it in the cloud if you want to, but then you lose privacy. Also there, you need edge computing.
That was actually a great introduction to what I would like also to point out that as a kind of a learning from us coming from all these Gs. What we are seeing is that we want to use our telecom networks to several more services. It's not only mobile broadband anymore, not only voice, but it's video, but it is also connected transport, smart factories, mission critical service. And then AI at the edge picked up some few use cases, DAIS as well. And what we see is that increasing the Gs here, we are increasing network complexity. And network operation is becoming really costly, a kind of a showstopper. So we believe as a learning that AI and automation and embracing really cloud native and very much in connection with the software architecture you mentioned, Sasi, that we can also flatten out this curve and be able to handle the complexity of so many other services coming to the telecom networks to reduce time to market, to reduce cost of ownership, and so forth. Yeah, bit of my learnings. And related to that also, Jovanka, we discussed a lot about the business dimension here. You're coming from a team. How do you think that we are evolving here?
Yes, we are, of course, in our research projects focused on challenges from the technological point of view, of course, but still we have to think also about business dimension, as we already discussed in AI at Edge. For example, from the telco point of view, first of all, we cannot think about having, let's say, dedicated platforms for each use case. It is not, as we already see in AI at Edge, that was one of the main focus, how to define and specify as much as possible reusable components, capabilities, functionalities of such a platform, connect compute platform, and a network and service automation platform, in order to be easily instantiated also for new use cases, not just from those 3 or 4 that we started with. So that is one side of business dimension. Let's say as much as possible. Let's say AI at Edge platform with reusable components. Then also include also in the, let's say, technical decisions such as where to place and how to place AIFs in a highly distributed and decentralized platform. We have also to include, for example, energy efficiency dimension, which is part of the business dimension, and, for example, final prices that we apply to our end users. Are we, let's say, earning money or losing money, providing that kind of capabilities? Let's say, for example, sharing mechanism, federation mechanism between different players, providers, and shareholders, without, let's say, building platforms in the same, let's say, same logical and physical place, and so integrate them instead of replicating them. That is, let's say, one of the elements in this business dimension.
Sasi, would you like to add on this from the software development for intelligent edge, that the importance of that, and how are we far from it, Sasi? How is the development today?
So software development, like we have been progressing a lot in all the dimensions, and also we are, plagued by, different complexities, different, new failure modes. For example, here, one thing what we need to think is like the failure modes in this software. We should have, when you are going to have very resource constrained devices at the end, and they are going to fail in different ways. So the data what you get out of this whole massive devices in the field could be having lots of issues. So your edge frameworks has to be kind of taking care of that failure modes of the devices, attacks, security attacks. How do you really make your small footprint software to be free from attacks, robust enough to withstand different attacks? That's going to be a big kind of field we have to think about. And at the other hand, you can have low code, low kind of or minimal code level of developments. Kubernetes, they are going to really help you in making them scalable. All microservices is going to help you make them scalable, but you need to add the fault tolerant dimension. We need to add the security dimension, and if you add encryption on top of it, or if you add enforcement architectures where you make sure that, because all these systems are going to be more dynamic, and the moment you have dynamic systems around, you need to have proper authentication. Even your services, what you provide, should be properly authenticated. The enforcement architectures which are dynamic should be evolving. So there is a lot more in the software front happening, and it's going to happen.
I noticed there that well, the geopolitical landscape has changed since we all began these projects. Now we are at the risk of having half of the network missiled away. And that was not before security was more like, yeah, if somebody plants a virus, etc. But now we also have to plan for that large parts of the infrastructure disappears. I see that in DAIS you have disguised this as self-organizing.
Yeah.
That is that you can start with just fractions of the structure. And we have the same in AI at Edge. We can do cold starts. If you knock everything out, pieces will start to, they will start and do the best they can locally. And then they will organize into larger and larger bunches.
So basically, one of our use cases is like a forest fire, detection use case. So we actually kind of drones fly around the forest area and then drop these, kind of nodes which can connect to this whichever available, network, and then form a cluster of itself, and then try to help the emergency services to reroute the traffic, or reroute the ambulances or whatever is going to come, or cut off some area from the forest fire. So there are many activities planned in that use case, which are more self-organizing nodes. Based on the connect, but as what you mentioned is a much bigger problem. Like if how much failures we can really withstand, and also selective usage of the ML models, depending on the availability of the time you have and the resources you have. That switching also is an important element.
We have also similar sort of like drones circling, providing not only coverage, but also computational capability. So they become a part of the compute connect continuum, so that you can aid an area that is in trouble.
Perhaps we should open also for the questions in the audience. We have one question from Ali Nazakat. One of the use cases in AI at Edge is virtual validation of vehicle cooperation perception. We have done some work on it. I'm curious how virtual validation of vehicle cooperation perception looks like. How can you do that? Perhaps this crowd is not the best one to answer that, but we can show just here, and I invite you, Ali, to enter in contact with the project. Is in our homepage, the reports and so forth. But we have as a main driver of the use case Polimi with a real fancy testbed, I would say. So yeah, I think that we do explain.
It is utterly cool. I have been there. And they put people in that little thingy to the left, and it's the world. You know, if you played video games and have these driving simulators, this is that on steroids. It's really, it is completely realistic, and then you can mix humans into the digital situation and see what assholes they are in the traffic.
And that comes how with a fancy test bed you can get really the principles of perception. Yeah. Let's see another question.
Neva, just let me comment. There are many results from this. For instance, that if you have the higher percentage you have of autonomous cars, and it's enough with 10-15%, then everybody starts driving better. Everybody starts driving smoother and become more helpful, etc. So if you start introducing autonomous cars, it seems like traffic flow and everything increases. You can halve the energy consumption with this, just because people drive smoother.
I have a slightly difference of opinion in that. So it works in certain societies, but I come from India, and if you if you introduce autonomous cars in India, if there is the gap is not sufficient enough, people will jump in inside, and then you are going to have longer and longer delays.
This was Italy. It's not that different.
Okay.
They also drive creatively compared to us Scandinavians.
Now, including here a Brazilian and another one that lives in Italy. So I say, okay, yeah, but Sasi, India is becoming one of the countries with more 5G telecom deployment. So yeah, perhaps
things will improve soon.
Yes.
With the biggest 5G rollout planned in the coming years, yeah.
Oh. Okay, we have one more question here from Flavio Bitro. I have a question regarding AI native vision. Could you please exemplify or justify why we need the AI native architecture for future networks? I can give a shot, but Jovanka, would you like to?
Yes, I can try to, let's say, to justify and or to explain
help you.
our vision that we, let's say, support both from Tim and Ericsson point of view, I hope. Why? Because as we already saw, that's let's say cloud native approach. We can let's say think about that we will in the future have AI native infrastructures or platforms or AI ready platforms. Thanks to the results already achieved with artificial intelligence in many other fields, let's say large language models, image processing, image analytics, huge amounts of data in the network are already available. They are already regularly produced by network elements. In the future, we think they should be even more, let's say, observable. So observability of the future networks or the future elements of the Connect Compute platform should be there. And on top of that, and thanks to that, a lot of AI could be a lot of needed AI, artificial intelligence models could be applied on top of that huge amount of data, because that is the first step to have observability and data produced regularly and continuously, and then benefit out of that data, analyzing data in real time as much as possible, and produce insights, and then understand what is happening in the network and how to anticipate and how to optimize performances of the overall system. That will be complex, and so AI should be used thanks to the data, but also to deal with complexity, because it is hard to imagine that humans, as much as excellent experts, should be able to deal with huge amounts of devices that we can expect in future networks. So that is sort of AI nativeness, AI nativeness that I foresee, for example.
Can I weigh in?
Yeah,
Yes, please.
We now have another industrial revolution thanks to the AI tools. We see productivity increases of 50% or more in many, many sectors. There are two, this is really good, of course, this is positive, but there are two challenges with this. One, it can only be applied, as you said, Jovanka, to areas that require very little data transfer, because you can't shuffle all of this data over to the American clouds where it is executed. So for AI to create even more value, we have to execute it nearer. And if we're to execute it nearer, we better optimize for it, because otherwise it's not going to work. So we must absolutely optimize this for AI. The other problem is, if the America First US president is re-elected and cuts the Atlantic cables, Europe will come to an absolute halt. Nothing, no economic activity will be able in Europe unless we do something about it. So all of these AI functionality we also have to create here it's better sooner than later, actually. So we must really optimize for AI.
And one another perspective is also legislation, because of shuffling the whole data also across political borders also comes to data privacy as well. So that's also one more motivation, big one, to have security, not only, but that will not be possible to shuffle data, for sure.
Adding one dimension, if I may, like talking about data, most of our AI researchers, they have been using some data sets which are probably outdated, made in long ago. So in another project, insect project, we really made quite some contributions, making whatever data sets we generate for our simulation work, we are trying to make them open access and then available to the community to do. And that's also kind of very interesting requirement from the European Union, to have your data sets being made publicly available for researchers in Europe to work further on. So if you have looking at a specific dimension of the problem, and we don't have enough data sets which can be, so for example, factory anomaly simulations, we don't have much data sets, which there is like network attacks, there are lots of data sets, but anomaly data sets are much lesser available. So those kind of things, there is a requirement, and it could be good to make the AI algorithms more work on local, more specific data sets. Yeah.
Thank you for those reflections. I was thinking that Per, how would you add on the societal impact of our work? This is something that we have been reflecting a lot.
We have made a lot of interviews and talked to a lot of people about what the use we could have. We still don't have, because it's not deployed. And we see that there are many areas. Sasi had the e-health. The demographic challenge has to be solved. The only thing that increases with the number of elderly is the number of elderly. So we have to do self-care, data-driven, technology-supported self-care. This is sensitive. You can't send it abroad. You have to have it locally. And edge computing would be perfect, because you would have your personal health assistant jumping from base station to base station as you move along. We also see, I work a lot with democracy and rural issues, rural development. In many rural areas, there's a lack of workers and lots of need for transportation. So we have to have autonomous vehicles. And it's much easier than in the cities. I can't drive in Berlin. So, but anybody, even autonomous vehicles, they can drive in the rural areas, like 2 roads. How bad can it be? So there are a lot of things that we could do now with the help of edge computing, and the list is very long. We have all seen these drones and all kinds of. We have looked at rare things like there may be agricultural challenges in the future, so we do need to do a lot more aquaculture. We need to grow things in the water. This can be done, and maybe very well if it's data driven. So you need sensors and you need data. Also a very good application for edge computing. So we believe that the societal impact will be humongous if we just get it into the field. I think the most important we have to do now is to convince Iovanka to go to her superior boss and convince that superior boss to go to Ericsson and buy some edge computing and launch it. So we get some, nationwide deployments. That's what we should do.
Yes, I already did part of that because supporting a EDGE project, participating in the EDGE project means exactly that. Team supports and strongly believe in that cloud edge continuum infrastructure, particularly European-based. We are very aware of that data privacy rules in Europe, and we think that European telco operators, based in Europe, of course, can be exactly the main player in that overall, let's say, European data infrastructure that we can imagine. Yes, based on cloud edge continuum, in order to provide. Completely, let's say, managed and sure data treatment of European citizens without moving that data to abroad, let's say, both from the societal and privacy point of view, but also from the economic point of view, because data economy is a huge business for some players. Yes. Extracting insights from the data, thanks to AI, for example, is the main revenue stream from many of the over-the-top players, while telco providers are dealing with huge amounts of bits to transfer, and let's say others are taking benefits of it, let's say. So we do think that cloud edge continuum is part of the solution for, let's say, 6G for sure, but beyond 5G, of course, and for, let's say, closer integration of connection and communication and computing. Let's say computing and communication should be closely collocated, related, and managed. So that is in order to provide better quality of services to many kind of already envisioned applications, but also to the future kind of applications. So that is data-driven and AI-driven. Yes, we do believe in that, in the cloud edge intelligent continuum. So
I want to say,
as soon as you have Per, as soon as Neva, as soon as you have some proposal, maybe like concrete with Bill, we can discuss for sure. That is the point. Data-driven economy and AI-driven economy for sure is there, and telco providers wants to be part of the joke.
I think if when the planet is dying in the sense they will no longer support human civilization as it is. We need to become smarter, and we humans will not become smarter. But as you say, Ivanka, if we extract much more data, transport and analyze that data, we as a civilization can become much smarter and do something about it. So I think it's absolutely the right track.
We have a couple of more questions here. How can we deal in case when we have a lack of data, or more precisely quality of data? A question from Alia. Yeah, anybody would like to take it?
I can comment a little bit on, if we have little data for training, there are methods that we started looking at, sort of data-less training, how you can find models in between data sets and similar IDs. So that is a little help maybe.
Or use simulations or that digital twins to create artificial data also, to have a starter for models. Yeah. Sasi, you are on mute, Sasi. Please.
DAIS also, there is some, one partner is looking at this, like lossy data or, kind of distorted data analysis framework. So I can, if the person mails me, I can get the details of techniques what are being used. That can be done.
That's a great idea. In the home page of the webinar, you can find the contacts for our speakers. So you are very welcome. Our last question then, from Bengt Algren. To what level do you think an edge compute environment with AI support need to be standardized? Or put it differently, what range of heterogeneity needs to be supported? Ivanka, I believe that is one for you.
Yes, very good question. Thank you so much. For sure, I think that that will be one of the, let's say, stream. It is already present, but in the future it will be very present in the standardization bodies on how to on standardization of the interfaces regarding data provisioning, let's say data collection, data pre-processing, data sharing, data analytics, let's say aggregation or transformation, and on the other side, how to deploy that, components with AI ML models inside of that components. That as AI at Edge, we somehow started to address, for example, providing the model of AIF, AI functions, providing AI function descriptor that is needed in order to deploy and as orchestrate that function across distributed and decentralized Connect Compute platform. There are some, let's say, starting points in order to standardize that part of the problem, let's say. For example, in Open Run, there are some works ongoing regarding deployment of so-called RAPs and XAPs, but only, let's say, related to the run part, radio access network, in order to optimize radio access network thanks to the AI models inside RAPs or XAPs. That is one part, but there is also in 3GPP, there are already started activities on how to support, let's say, artificial intelligent models of third parties that are running, for example, at inside end user device. AI at EDGE has not been, let's say, involved on that part or end user device so much, but there are also that part of questions. So that is going to be, in my view, a part of the activities in next year in standardization body. As I already said, in ORAN, it's already there, but for the RAN part in 3GPP, also for core and also for the management part, then somehow it should be all coordinated, let's say, in end-to-end orchestration. So data collection, data acquisition, data management, and let's say deployment of AI models over a distributed platform. Yes, that in my view, that are part of the solution.
Thank you so much, Jovanka. We are a little bit over the time, so I would like to thank you so much, the speakers from Lithuania, and my word to Irene.
Thank you, Niva. And
yes,
can
please go ahead. Please.
Okay. So thank you all, and thank you all the speakers for joining. Thank you, Niva, to be the moderator for today. And thank you all the people that have joined our webinar. Just some information, the webinar has been registered, so the video will be made available on the YouTube page of the project, so you will see soon be able to see it again if you want, or to share with other people. And thank you all. And I just want to announce that we have the final webinar of the EDGE project. You will soon receive some information, so you can just get in touch, remain in touch with us through LinkedIn, and you will see a final webinar of the project. And thank you so much, and I wish you all a nice day.
Thank you so much. Bye-bye all.
Bye-bye.
Bye.
Bye.